Hi, you're listening to the NewSpace India podcast, a bi-weekly talk show that exclusively brings insights from the Indian space activities ecosystem. I'm your host Narayan, the co-founder of India's first space-focused think tank, Spaceport, Sarabhai. Guests on the NewSpace India podcast help you understand space activities-related macro and micro trends within India in all aspects, including space history, local industry, space science, technology evolution, law and policy, art, and more. The NewSpace India podcast is supported by Dassault Systems, a global leader in providing businesses and people with collaborative virtual environments to enable sustainable innovations. Dassault Systems Solutions supports startups, small and medium-scale enterprises, and original equipment manufacturers in developing disruptive solutions for space launchers and satellites. Hi, and welcome to yet another episode of the NewSpace India podcast. And today we have Gurbir, who's back on the podcast. And Gurbir is currently working on a new book, The Atlas of Space Rocket Launch Sites, published by Dome Publishers in Berlin. It's a very interesting and exciting book that talks about the various space launch sites that are around the world. And it obviously includes India and the two launch sites that are there that are up and coming when you compare that to other launch sites around the world. So, Gurbir, thank you so much for taking the time and recording this episode with me. And I think all your books are fascinating because you pick themes that not many people pick.
You always say that, NP. You're dead right. I do write to books that I'm interested in. They're not all necessarily have the wider appeal, except this one. This is very unusual. And it's a book that, the idea of the book, when I first heard about it, I thought, that sounds really good, interesting idea. How come nobody else has ever thought of this? And what this book is, it's quite a large format. It's slightly larger than A4, so you can't really carry it in your pocket or anything. And when you open it up, it's about A3 size. And a lot of the pages, about 270 odd pages, are full of pictures, mostly color. In fact, almost all of them are color. And some really terrific and high resolution maps of the sites that we speak about. We speak about almost 29 satellite sites around the world. And it's a product of about 4 people. We started doing this in 2019, and had the pandemic not interfered, we would have finished a bit sooner. The book is produced and edited by, and the original idea came from Paul Mauser, and he's part of the family business of Dome Publishing in Berlin, who are publishing this book. And it's also supported by Katrin Soshensky, who's a cartographer. And I think her exquisite work in this is really the reason why it's called an atlas, because it really does give you a flavor of where all these places are and the topography of many of the sites. Most of the writing has been done by the well-known space historian Brian Harvey, and he did most of the sites as well as the introduction, whereas I just really did the least. My contribution has been the most minimal. I discovered the launch sites in India. And it came about because Paul had approached Brian and me back in 2018 to write on another book about the architecture of the moon. It's called The Architecture of the Moon, but that's because of the Dome Publishing has a history of publishing books on architecture. But this Atlas of Space Rocket Launch Sites is, I just heard a couple of days ago, now available. It's only available in hard copy. It has a glossary, an index, and a further reading list as well. And as far as the sites are concerned, and we'll talk about the individual sites in detail, but generally speaking, what we've done is broken up all the 29 sites into 5 groups and given them very unusual names. Now, I should say that this is completely arbitrary. We could have written about the launch sites in some sort of chronological order, or where each country, in terms of the countries where they lie, or perhaps in some sort of sequence of how many launches have taken place from each of these sites. But in the end, it's just a geographical location, and an arbitrary one at that. So the 5 groups are the Americas, Balto-Mediterranean, Eurasia, Indo-Africa, and Asia-Pacific. So this, and right at the beginning of the book, you'll see a world map, and these groups are identified. And I just want to make one final point at this stage. We covered sites or spacecraft have been going into space from ships, submarines, aircraft, and of course some aspect of sea launch, whether a modified oil rig or indeed ships. And so you can get into space in many ways. And in fact, historically, before the Second World War, 30s time period, there were people experimenting with launching rockets from kites and balloons. And neither of those things were, of course, launches to space. But the idea, the principle, was considered even then. But we are, in this book, only looking at sites which are used for orbital launches rather than suborbital, and they're almost all on land. There is a sea launch option that we cover, and San Marco, the converted oil rig. The idea of including some sites, we've got some sites which are no longer in active use, but wanted to include them because of their historical interest. And they include places like Woomera in Australia that British used, Algeria in Africa, which was used by France, and the one not very far from where you are, Peenemünde in northern Germany. So other than that, all the other sites are pretty much operational today.
And before we get into some of the interesting details, just anecdotally, have you visited many of these launch sites? I know that you've been in Sriharikota, but any others?
No, and I haven't. One of the questions I was asked recently is which is my favorite. I have been to a couple of places in the US, but mainly for the research for my Indian space program book, I visited Sriharikota and Thumba times, but no, most of these sites I've never been to, and I am going to call on your expertise because I know you've visited one or two that I haven't.
Yeah, it's always interesting. I think the experience of visiting launch sites, and it is so different from every country is different. And especially I think the ones in the US are like crazy big. So it's unimaginably big because the country is so big, right? At the end, I haven't really seen a lot of this kind of material put together very interestingly, but obviously there are some critical analysis on launch sites that are published as maybe research articles or so on. What was your discovery process when it came to putting together a book like this, and what is the motivation?
So the motivation was, to say, the idea came from Paul Mauser, and it was such an interesting idea that I really did want to be involved. But you're quite right. Just about every site we speak about, you will find something written about it somewhere. Unfortunately, there's been never a single book that covers all of these in a consistent manner. And we did have to make some choices, saying that there are sites covered which are no longer operational, but that formed part of the story of launch sites, which goes back quite some time. And it shows how countries and nations have developed their own space programs and capabilities, along with the changing background. The backdrop, for example, of Syria was a former French colony, and that's why the third country to launch its satellites by its own facilities was France in October 1963. Now, that happened outside, well away from France, and eventually when Libya became independent, they had to leave, although for a while France continued under license to use that site. But now it's moved over to French Guiana, another former colony. And in the case of Australia, in the late 1950s and early 60s, when Britain was developing primarily the nuclear deterrent, as it's called, they needed some places which are very large-scale, empty, uninhabited places, or at least that's what they claimed, to develop these really quite dangerous rocket technologies and, of course, in UK, they tested their nuclear devices in Australia. Europe has traditionally been too populated for things like that, and that's why the European powers used to use these faraway places for testing. So in terms of including sites which are no longer used, we decided to particularly include those three, Gurbir and in Algeria, and Peenemünde in northern Germany. And in fact, a lot of people think that the very first space object was Sputnik in 1957. Of course, that was the first orbital satellite launch. But prior to that, it was in 25 years earlier in Peenemünde, the A4 or the V2 rocket that was being developed by Germany during the Second World War, that in 1942, October the 3rd, the very first human-made device crossed the threshold of space. And that was the V2. It was a suborbital flight. It was being very early stages of the success of the V2. And that's considered crossing the 100-kilometer altitude space threshold, the Kármán line, named after the American-Hungarian scientist Theodor von Kármán. And that, in 1942, was actually the very first entry by humans into space.
That's very interesting because just as an additional anecdote, especially on Peenemünde, I previously, many years ago, was at DLR, the German space agency. And since I was employed within the space agency, I had a chance to go visit the Peenemünde launch site. And one of the interesting things there is that they have a public part of the launch site where there is a museum and people can see what kind of activity was going on there and some pictures and so on. But then there is also a restricted part of the launch site, which is closed off for the general public because the Allied forces have bombed that place so much that the German government has never had the resources to go clean up that area for any unexploded bombs. So you can only visit there after special permission, and you have to sign a letter that in case something goes wrong in that particular launch site, when you're there and an unexploded bomb goes off or something, then the insurance or something like that is not liable for you to cover all the expenses and so on. So this is a very interesting part of Munda's existence to a large extent.
So you've been there. I haven't. I know Brian Harvey, who wrote that section, has also been there. So if people want to go there and do what you did as a member of the public, German public or a tourist to Germany, can they do that now?
No, I don't think so. The general public is still not allowed into the restricted area, and there is security that cordons off the restricted area.
And it will be for quite a few years. Can I talk about anecdotes? I'll give you a couple of anecdotes as well at this end. The first one, back to Peenemünde, because it was quite a dangerous development as far as the Allies were concerned, these super weapons being developed in Peenemünde. In 1943, in August, the British Air Force conducted a bombing raid off Peenemünde, and they destroyed quite a lot of the material facilities there. And Werner von Braun and Hermann Oberth were actually on site at that time. And they both survived, of course, but many of their colleagues didn't. And Hermann Oberth, who was there incognito under a different name, in that von Braun's parents visited the site following the raid just to make sure that he was okay. And he was complaining that these were people who were unclear to make such a visit. This is in some testimony in the back in the 1980s, just before he died. But it's quite interesting that these things came out near the end. And also, there's a well-known name associated with the development of rocketry, at least in space, Arthur C. Clarke. He was working by then for the British Air Force on a special, like an ILS device, an instrument landing system, which allows airplanes to land on runways with instruments rather than being able to see where they're landing. And this was a very early, at that time, top secret device. And he was working at that time. And when these bombing raid concluded and the RAF airplanes came back to the UK, he was using this device to help them land. He didn't know what mission they'd gone on, of course, because he was by then promoter of spaceflight. So that's quite an interesting thing. And just one other thing, going back to India, you're probably familiar with a guy called Felix Baumgartner. Have you heard of that name, Narayan?
It rings a bell.
It was quite some time ago.
Oh, yeah, the guy who went to space with Red Bull. The guy from Red Bull, the Austrian guy who went to the edge of space.
That's the one, absolutely. So he was called Felix Baumgartner, and in October 2012, he went to an altitude of 39 kilometers in a balloon, then jumped down, and he did the free fall and balloon parachuted down. But about 2 years later, in October 2014, a guy called Alan Eustace, who was a former Google executive, he went up slightly higher, 41 kilometers, and did the same thing. And interestingly, that balloon used by Alan Eustace was made at the TFI, Tata Institute for Fundamental Research facility in Hyderabad, which is, not many people know, but one of the leading institutions for high altitude balloons is in India, in Hyderabad.
Yeah, that is super interesting as well. I think it may not have received as much publicity for such a feat in the regular Indian press.
No, and it was only, I covered it in my book, which came out in 2017, but I saw some stuff on social media because it was recently the anniversary of that event. But yes, it's quite right. There's so much stuff going on in India that you don't always get to hear about.
Yeah, absolutely. So from the early launch site that you talked about from Peenemünde and so on, so what is the sense of how these launch sites have evolved per the study that you had to do in putting together the book?
So the general story for most of the launch sites is that, especially the early ones, is that they have their roots in colonial occupation of these countries, of these lands, because most of the colonization was conducted by European countries, France, Belgium, Britain, of course, Spain, Portugal. Most of these countries are, being in the heart of Europe, don't have the wide spans of open land to conduct these tests of high-speed rockets and high altitudes, because especially when you're doing this at the early stages, you don't have the control, so you're not quite sure where they're going to land. So in both France and Britain's case, their colonial locations like Gurbir and Woomera in Australia were selected for doing these things. They just could not be done in places like Europe. And also it's interesting to note that with the exception of India, I think it's fair to say that most of these were developed for conveying military armaments. So delivery of initially normal bombs and then later the atomic bomb. And in this case, that tradition still persists today. So places like Vandenberg Air Force Base, which we'll talk about briefly later on, is on the west coast of America. Everybody's familiar with Cape Canaveral, but Vandenberg is and has been, still continues to have a very large proportion of its activities for military use. And this is true not only for America, but other countries too. And many of the up-and-coming commercial launch sites, which we didn't really explicitly cover in this book because they are, at this point, quite new. The other one that just recently, and just made it into the book, was Kodiak, which is in Alaska, which also has a very strong military background. But in India, certainly Thumba, which was the very first site to be used to launch a spacecraft from Indian soil into space back in 1963, started off not only on a peaceful basis, but also for scientific research was its main purpose. And the reason why Thumba was selected was primarily because both Homi Bhabha and Vikram Sarabhai, who were heading this project up on behalf of Nehru. In fact, given that Sputnik and the American Explorer had launched to space, it was found quite important that even though India was still about a decade old in terms of independence, that their future, the future of India, lay in new technologies, and space technology and atomic energy as a power source and fundamental scientific research were considered to be the important bedrocks on which a new nation should be built. And that was the principle that drove Thumba. And Thumba in particular had another reason why it was selected as a location in India. And it's because by chance, one of the phenomena of high altitude physics is this thing called the electro-aerojet. I've forgotten the name of it. Just give me a second. That's right. It's the equatorial electrojet, the EEJ. And the electro-aerojet is a high-altitude flow of charged particles. So it's actually an electric current. And in order to investigate that, this was quite new in the early 60s, and in order to investigate that, the only way you could get some instruments into that was by rocket. So the Thumba location was chosen because it's located directly below the EEJ. And in the end, later, after it was been operating for a few years, it was inaugurated as a special site where anybody part of the United Nations could come in and conduct experiments. And many sounding rockets, these are suborbital small rockets that would go up and then come back down again and collect data whilst they were up there. These launches were conducted from countries from all around the world, including the Soviet Union. And it's quite interesting that places like this, which are founded on basic science, is where usually the only places where scientists from otherwise competing political ideologies could get together and communicate, whereas elsewhere that kind of close communication and cooperation was really forbidden. So Thumba played quite an important role, as well as being the site of India's very first launch on the 21st of November 1963 for its very first launch into space using the Nike Apache rocket that came to India from America.
Yeah, thanks for that really interesting set of anecdotes and history behind all of these things. So basically, I think what is, again, part of all of this is how these launch sites have evolved over time and how they've been maybe looked at for different reasons. I think it will be interesting to get a sense of going from Peenemünde, that is a more a military purpose. It was looked at for as a missile launch site. And then going from there to being pole launch sites are very different, looking at going into the lunar orbit and so on. And now you have a lot of the private launch sites coming up as well, like the one you have in New Zealand, it's a rocket lab. So are there any interesting insights around the location of these launch sites that you can share? Obviously, there is a factor of which orbits you want to launch and the advantage of launching from certain latitudes that are there. But beyond that, are there any interesting insights that you have that you can then share?
Yeah, so I'll go through some of the launch sites, but generally speaking, in terms of orbits, it's a very important aspect you mentioned there. There are two types, there's many actually, but I'll just talk about two types of orbits. One is when you need to get into what's called a equatorial orbit. An equatorial orbit is the sort of orbit that you can imagine looking at the Earth. It's the horizontal along the parallel with the equator. And those are geosynchronous orbits, which is where the satellite, if it's at an altitude of 36,000 kilometers, then the rotation around the Earth is the same time as the Earth takes to rotate. So they appear to be in the same part of the sky every day. So most of the communication satellite dishes you'll see, certainly for reception of TV, are pointing to a geostationary satellite. And that's why once you point that geostationary satellite receiving dish, you don't need to move it again. So your satellite TV to be located at the same satellite and you continue to receive the signals. That's because satellite doesn't move. And that's made sure by a little bit of station keeping on part of the satellite operators, but that's a geosynchronous orbit or equatorial orbit. And in order to launch there, you have to launch essentially, ideally, eastwards. And I'll come back to this in a moment. But the other type of orbit is a polar orbit. And a polar orbit, as you can imagine, launches in the direction of north to the North Pole or south to the South Pole. just depending upon local geography. And that, as you can imagine, the pole, it's a vertical orbit going around the North Pole and the South Pole and continuously doing that whilst the Earth is rotating underneath. Most of these satellites are used for remote sensing. They are also used for meteorology, of course, and observation. So these satellites, they need a trajectory north or south of the launch site. And I should just mention also that although we think of rockets going up, and that is quite understandable because when we see a rocket launch, it just goes vertically up. But in practice, the force of the rocket has to be horizontal. It needs to have a certain speed. Otherwise, the spacecraft will never reach orbit. And that speed for low Earth orbit is about 8 kilometers per second. So once the rocket takes the spacecraft above most of the thick atmosphere, let's say about 30, 40 kilometers, then you will see that the direction of the spacecraft, depending upon its desired orbit, and it's that horizontal spin of the Earth that's the reason why launch sites are always on the east, head east, and therefore what you do want, because of this idea of staging and the potential failure of the launch system, you want the launch site to be on the eastern coast so that if there are problems, the launch vehicle will come down at some unpopulated area in the sea. So most launch sites are on the east coast for that reason. However, one site that we do cover, which is in Israel, called Palmachim, is, if you look at the geography, you'll see that Israel has Jordan, Iran, and Iraq towards the east. So it has to launch west. And by choosing to do that, by having to do that over the Mediterranean Sea, it loses out because it's going down in an upcoming escalator, if you like, and it's inefficient because of that particular requirement. And why does it have to do that? If the launch is unsuccessful, it could cause some damage on neighboring countries, or indeed allow some of its IP, the information in its software or on its memory boards, or indeed the circuit boards, or indeed whole payloads, which might end up in what they might consider as enemy hands. So these launch restrictions force Israel, the only launch site that we've looked at that, if you like, launches in the wrong direction. And by that I mean, if you're on the equator, you launch east, you get a helping hand of the Earth's rotation of about 500 meters per second. This is speed that you get, which you otherwise would need to have fuel for, which means that the whole spacecraft can either be bigger, can get to a further distance, and because it's making use of that additional spin from the Earth, it's much more efficient. But most launch sites are on the east coast. I mentioned Vandenberg, and Vandenberg is on the west coast, so most of the launches from Vandenberg are polar launches. And Cape Canaveral, which is perhaps the most famous launch site in the world, has had a history of polar launches, but there are, from the geography, a polar launch from Cape Canaveral means flying over Cuba. And that's a problem for the US and indeed for Cuba. So the polar launches are conducted from Vandenberg. And coming back to India, one of the reasons why there's a new site, Visakhapatnam, as you mentioned, has been selected. It's on the southern tip. So if you imagine India as an upside-down triangle, we're looking at the pointy bit at the bottom. You've got Thumba on the west coast and this new one on the right, on the east coast. And launches to polar orbits from Sriharikota had a dogleg maneuver to avoid Sri Lanka. If you launch polar orbit from Visakhapatnam, then you don't fly over Sri Lanka, and therefore it's a much more direct flight. And if I just talk about this new site, which is only just got clearance to start building the launch pad, it's been in the pipelines certainly for 2 or 3 years, and even before that, there was a lot of debate that we call it the second launch site in India, because although Thumba is still used for sounding rockets, it's not actually. No orbital launches have ever been conducted from Thumba. So this new launch site will be used primarily, it's been announced recently, that it will be used for the new launch vehicle in Israel, which is the small satellite launch vehicle. Everything in India tends to go a little bit slower, and it's not quite clear when that will happen, but the FV has yet to go through a few more tests from Sriharikota before it's operationalized a few years to go. And then just finally on Sriharikota, it's the one that I know the best. It's one I've been to a few times, and it is a very beautiful place. Of all the other things you could say about a launch site, many sites, because they are usually in the very isolated parts of the country, and this goes for places like Woomera, Vandenberg, and Cape Canaveral as well. In the case of Sriharikota, you go there by a small road, a signal road, which goes across Pulicat Lake, and it's a bit like an isthmus. You've got water on both sides, and in that natural environment, you have kingfishers, pelicans, flamingos, and a whole heap of fauna and flora that is really of unique, special environmental interests. And just one last thing about the launch sites in general, in Thumba here in particular. A lot of, as we know, we're having COP27 starting next week in Egypt. The environment is quite important. And the way that the space industry has been developing, it's pretty much has a history of not being all that responsible when it comes to environmental use cases. But in the case of Sriharikota, there are guidelines that determine when launches can take place. And indeed, those requirements have to be fulfilled in some cases for launches to take place. And I saw a recent post about the SpaceX Starship, and they have to get licenses from the FAA, and sometimes those license requirements oblige SpaceX to ensure that environmental controls for the site from when these launches take place adhere to. Otherwise, no licenses and no launch.
I think all of that is really interesting information. So how many launch sites are there as of today? And do you have any insight into the frequency of launch into these places?
So it varies, and it was quite a tough choice in picking the sites that we did choose to write about. As I was saying, the criteria is something that we felt that we had to write about. Some of the former, now no longer operational sites, but we could have selected others too. If I just go through very briefly, in the Americas, this first group, we have the Kodiak in Alaska, the new military/commercial launch site, Vandenberg. And if I just take a moment to explain something special about Vandenberg, which is something that Brian wrote about and I wasn't aware of. Vandenberg was the secondary launch site for the space shuttle. Now, no space shuttles were launched from anywhere other than Cape Canaveral. However, Vandenberg was the secondary site. It was going to be coming online as a launch site for the space shuttle, but the disaster in 1986 brought huge changes, and it never was. So Vandenberg did have this device called a demating device, which was a facility for putting the space shuttle on the top of a 747, so it could be flown from Vandenberg to Cape Canaveral, and indeed before that it was used for some of the unpowered glide tests as well. So that facility existed and was built especially at Vandenberg. They had a huge runway developed there for an alternative landing facility in addition to Cape Canaveral. And they had the launch towers as well as the shuttle assembly buildings. All that infrastructure was built and it was going to go live in late 1986, but the Challenger disaster forced a huge change in the policy by the Reagan government that all that infrastructure never was used for that purpose. Just a couple more anecdotes. This is a story again. I don't think this bit's in the book, but I was surprised to learn when I was doing research that because Space Shuttle used to launch from Cape Canaveral and go over the Atlantic, one of the potential backup landing sites was a disused airfield, which was of course operational for the times of when it was required, for the space shuttle in the UK, in Kent. Kent is just on the east part of London. And I never knew that this was a potential backup landing site in case of an emergency for the space shuttle. And just the other anecdote which I came across in my book, The Indian Space Program, was that because of the Challenger disaster, 1986, the second Indian astronaut who would have been launched from by the space shuttle, this is following the 1984 launch of Rakesh Sharma by the Soyuz in the USSR, second Indian astronaut would have gone on board a space shuttle, and it would have been either P. Radhakrishnan or N.C. Bhatt. They were training out there and had conducted pretty much most of the critical training when the Challenger disaster happened. And as a result, again, the Reagan government decided not to develop the shuttle in direction of the international involvement it had planned and the commercial aspects to it. So they never got to fly. And still, Rakesh Sharma is the only Indian to have flown, but with the Americans, with the Soviet Union, beg your pardon. And then if I just mention, I'll skip over Cape Canaveral. It's the place where, of course, men went to the moon for the very first time, and the place where the very first space satellite was launched from America, just a few weeks after Sputnik. And then there's Wallops Island, which is further north on the west coast. And that, again, has an interesting aspect and connection with India. Wallops, like most others, was developed as a military use initially. And it's where the Indian and Pakistan rocket scientists were sent for training. So back in the early 60s, after Sputnik and Explorer 1, both America and the Soviet Union decided to support and help other nations to develop their own space programs. And one of the ways they did that was to bring people in from other parts of the world, including India and Pakistan, to make sure that they had the training necessary. So people like Abdul Kalam, who was there, Ale, Murthy, a few others went there. And I remember Ravamudan's book talks about meeting up or being aware of at least the Pakistani scientists who were their peers. And it was quite interesting that at that point in time, in 1962, the development of the Indian space program and Pakistani space program was pretty much the same level. After that, of course, things grew in different directions. And Pakistan still has an organization for space research, but not really a substantial one. And if I then carry on to the Pacific region, we've thrown this in there as well, the Kourou, French Guiana, where most of the Ariane 5 and soon to be Ariane 6 launches take place. And then most of the heavy 2-ton, 3 or 4-ton satellites from Israel are also launched with a commercial collaboration with Ariane Group. And just mention one other web launch site, which is Alcântara in Brazil. It has a very sad story. No launches from there at all, but it's a huge launch site, one of the largest, about 620 kilometers square. There are, as most countries, political stability and economic are prerequisites for developing this area. And although nothing yet, hopefully that will develop soon. And if I move on to the second group, this is the Balto-Mediterranean, the Hammaguir in Algeria, which is where I was saying earlier that the very first French satellite, Astrid, was launched from in 1960. Peenemünde, we spoke about this special, unique place in history for that, and Palmach in Israel, which has a unique direction of launch. And then this area, the third group is called Eurasia. And here we talk about the other now well-known, but initially very secretive sites in Russia, Plesetsk, Caspian Yar, and Baikonur. And it's interesting to note that Yar is where the very first and second satellites launched by India, or rather built by India, was launched from. And I've seen some video where I see a very young Professor U.R. Rao, who's visited Caspian Yar very frequently, following the offer from the Soviet Union to launch an Indian satellite back in 1971. And mostly driven by U.R. Rao, the first satellite, Aryabhata, was launched in 1975 and that was pretty much a secretive site, and still at that time remained a very popular, very busy site. It's still active today, of course. And today, there is another site in Russia called Vostochny, but we've had to geographically put that in a separate group as well. And Baikonur, again, historically a military site, and it's it's named after a town called Baikonur, but it's nowhere near that town. And that was part of the subterfuge of the Cold War in using that name for it. And Kapustin Yar, as well as being Baikonur, as well as being famous for Sputnik and Gagarin, was also where most of the Interkosmos program launches took place. Interkosmos was the name of the program the Soviet Union gave to a series of launches of astronauts from other nations. This was part of the Cold War ideological struggle to get each non-aligned nation to think more highly of either communism in the Soviet Union or democracy / capitalism in the West. And that was the name program that Kishama flew under, went to space in 1984, but astronauts from Cuba, Poland, and even Afghanistan made a similar journey from Baikonur. And I just mentioned one other thing about Baikonur, which not many people are familiar with. It was hidden in secrecy for much of its time, that something called the Needlin disaster. And that happened in October 1960, when it's not known exactly how many, the numbers are controversial still, but about more than 100 people were killed because a rocket second stage blew up on the platform, on the launch pad itself. And this is a kind of disaster which, had it been better known, would have perhaps made launching and launch site procedures much safer. Today, as you can't really most of the fuel loading is done remotely. So hardly anybody is near the spacecraft, the launch vehicle, once the loading starts. Everything happens remotely from usually 3 or 5 kilometers away to avoid things like this. It's extremely hazardous and dangerous materials. And then if I just move on to the fourth group, that's called the Indo-African. And it includes this disused, customized oil rig platform called San Marco. It's off the coast of Kenya, and it has been used in the past for very successful launches. You probably don't remember, but there was a 1980s satellite called Uhuru, an X-ray investigation satellite, and that was launched from there. It's named today as the Luigi Broglio Space Center. It's operated by Italy, but it's in international waters. And although it's not been actively used as a launch site, it's still used as a ground station, I believe, even now. Thumba, Kulisakrapatinam, and Sriharikota we've spoken about. They also form the Indo-African group. And the final one, this is called the Asia Pacific. So China, and I think to answer your question specifically about where most of these launches are taking place, I think for the last 2 or 3 years now, the number of launches coming out of China has been really impressive. Of course, Starlink launches from SpaceX is just keeping up the launch cadence in the Cape Canaveral as well. But the China's Jiaquin, Xishan, Wenshan launch sites are very active. Indeed, there's a launch site China's been using recently from a ship, I think called the Dibo 3 launch platform. So China has, in addition to 4 launch sites on land, is now actively using ship launch as well. And if I just mention the North Korea, the DPRK site, most of these sites they have been launches, but what they claim and what actually happens is very unclear. But as well as South Korea also has launching facilities off the narrow Korea Island launch site. I mentioned Vostochny, which is a Russian launch site. It's in the Asia Pacific group. It's one of the newest, and it's far away from Baikonur, which is in Kazakhstan. Incidentally, following the breakup of the Soviet Union, the Baikonur launch site's been used under license by Russia, and that's why they've recently operationalized Vostochny, which will mean that less reliance on a third-party owned launch site. So Vostochny is new. It's got a whole city around it now, and it's first launch, I think, took place a few years ago when President Putin was present. They had to delay that, but it's the current situation in Ukraine and Russia has really affected the number of launches taking place. And then finally, Japan. Japan has really 2 active launch sites and is still a very active player, particularly for science and exploration launches. Plays an active role in supplying resupplying the ship to the International Space Station. And although there are many more commercial launches now, we only covered the Mahai Rocket Lab site that you mentioned earlier, where the Electron is being launched from on a more regular basis. And it's surprising how successful that has been for a commercial launch site. And from New Zealand, it's really come up really successfully very quickly. And then the last one that we cover here is something called the Sea Launch System, which has another troubled history. We call it, it's actually business name, its company name is Sea Launch. And it's a conglomeration of many different countries, been operating launches from sea. It's got a very troubled history. It's not launching anything or hasn't launched anything quite recently, but I expect that to develop with perhaps new players in the private space sector. So I've gone through quite a lot there. Just get back to me with any specific questions on any of those sites that I've mentioned, Narayan.
Yeah, thank you so much, Gurbir. I think that is quite really extensive. I would say what would be interesting to know is from your analysis and also looking at the history of a lot of these places, do you see any trends towards, at least in a lot of the countries, these spaceports being taken over by private people and private companies, that they could also launch some of their rockets that are increasingly getting privatized?
Yeah, the process and expense of building a launch site is quite a daunting task. As with what's happening in India for startups to develop their own static launch site, launch facilities, for example, is quite a challenge. In India's case, I think ISRO is providing those facilities. And as the commercial space sector grows, this need will develop. And that's why I think these new sites are bringing in a lot of new innovation. We've seen these remarkable sites of SpaceX boosters coming back to land and being reused. I think Rocket Labs announced that they're hoping to recover their boosters, and they're using a different technique. They're going to use a helicopter to catch the descending booster for reuse. So that's the nice thing about the private sector for commercial launches. There are quite a few. I think there's one being developed here in the UK. In the UK, there's no rockets have ever been launched from the UK. However, the Virgin Orbit program being developed in Spaceport Cornwall is in the southwest part of the UK, is using the air launch mechanism by using a converted 747 with a rocket under its wing and taking it out over to the Atlantic and then dropping it. And then from there, the rocket powers itself to orbit. That's a horizontal launch. And in the UK, there's also plans for a vertical launch, traditional launch, but that's going to be taking place from way up northern Scotland. They're under development. These are commercial operators. And I remember, I think it was this year, that there's a commercial launch provider in the Northern Territories of Australia. And so there is a lot, and I think it's actually sufficient there for another book in a few years once these commercial players get started. But that's how I think the future of commercial launches, small-scale launches, will develop, because there is a lot of business there, especially for small launch vehicles, which is already developing, and as the costs come down, it's bringing in more companies and countries which up until then did not see themselves as having any sense of space capabilities. But that is now available, and that's all thanks to the commercial space sector.
Really interesting, and thank you so much for sharing so much information. I mean, I'm very active at the time. We've recorded like almost an hour, and I do want to leave something out for people to gather in the book itself. But when is the book out, and how can people access the book? The book is out. It's available in Germany already, and I got some notification that it will be available here in the UK too. It is quite a big book. As I was saying, it's in colors, lots of pictures. It's
quite expensive at 98 euros, and it's only available in hardback and in English at the moment. I understand there might be some plans for bringing out a German version, but it's just a hard version available. And I will have, along with Brian, we will have some copies, and if anybody is interested in getting these directly from the authors, signed copies, they can contact me or Brian. But I'm still hoping that the price will come down. Already made my desire known. But yes, the book is already available, hard copy only, no ebook, no audiobook.
Yeah, I hope there is some sort of a wider distribution thought process that will come into place for sure. Good luck with that. And I will link publisher's information as well as the link from the publisher in the show notes of this particular episode. Yeah, thank you so much, Gurbir, for taking the time and recording this with me. And I look forward to obviously reading this book and enjoying the pictures from it, and then hope to catch up with you in the near future in person.
Yeah. And I just wanted to mention one thing that I touched on, but it's worth emphasizing. One of the things that I really didn't appreciate what was going on when I was writing the book about the Indian space program was the incredible dislocation of people that takes place when these launch sites are established. I mentioned these are vast spaces, hundreds of square kilometers, and usually there are always people living in those communities. And I hadn't appreciated this when I went to Sriharikota, but there's a lovely piece written by Asif Siddiqui, which I know you've had as a former guest on this podcast. And he writes about particularly the Yanadi people in India who've really not been given a fair deal when they've been forced to relocate. The same sort of thing happened quite recently at Kulasakarapattinam, but that was a bit more controlled, a bit more sympathetic from my experience, which is very limited and at a distance. But one of the things that we need to keep in mind, and I think Paul talks about this in his foreword, is about the environmental impact of spacecraft, which, of course, in terms of this book, have a significant on how launch sites are constructed and the environmental impact, because as we've just concluded, this is only going to grow. So we need to keep an eye on how we treat the people and the environment as we go forward. And there is a link to a piece written by Asif Siddiqui for further reading, which is, I think, also part of the important aspect, which we didn't really cover in this book, but there is a link in there under further reading.
Oh, thank you so much, Gurbir. I think, again, it's really interesting, all of these things. And I'm really fascinated by all the work that goes behind in digging out a lot of this kind of information. And also, I think these are things that are very unusual to research on. And you having time to having done all of this and sharing this with the wider world is really interesting. So thank you very much for all the work that you do. And then I hope the very best for the book and its success.
Thank you very much.
Thank you for listening in to this episode of the NewSpace India podcast. If you enjoyed this conversation, please share this episode with anyone you believe will enjoy listening to it. You'll be able to find the NewSpace India podcast in any of the podcasting platforms that you may be using, including Apple, Google, Spotify, YouTube, and others. Do subscribe to the podcast in case you want to receive new episodes automatically. I'm grateful if you're able to leave a rating for the podcast, which will help others discover it. Thank you for listening in again, and the next episode will be out in the next 2 weeks as usual.